Sorry guys, I didn't realize my first video had stopped, so I was going on there and then I realized it stopped filming. So here it is. So all I've done is do what? Plug in the 3 and 2, right? Plug in the upper limit of integration. The other thing I did is reduce the 16 and the 4, 4 and the 2. So I have plug in the 3, right? 3 to the 6 over 6 minus 4 times 3 to the 4th, right? Plus 4 over 2 is 2, 3 squared minus 3, and then do the same thing, plug in the ones. So put all that in your calculator. Again, your calculator will be your best friend. If you put this in your calculator, it looks to me like I got a negative 187.5. Put this in your calculator. We're getting a negative 2 and 5, 6. Again, you could just put in a decimal anyhow. This one's a decimal, so that's fine. So subtract these. Don't forget to multiply by a half. Then your final answer is going to be negative 92.9. Now, this is not square units or anything. It's an average value of a function. So if you look at all the values of the function on this interval from 1 to 3, the average height, yes, between all these y values is simply going to be negative about 93, right? So that's what that simply means. It's a number. Don't put units to it for once. Okay, so let's continue. Here it is. Let's just find one more. Same thing. All we're doing is just practicing. Now that you know what it means to find an average value of a function, what the formula is, it's finding definite integrals all along. So find the average value, then we just do some wordy problem. So find the average value of this function f of x is 2 squared of x minus 3 over squared of x from, or on, it doesn't matter, 4 to 9. Okay, so what's going to be the average value of this function? It's going to be 1 divided by, don't forget, many students forget about this. You just go on to find the area under the curve. But I'm just going to stop right there. But many students forget about this 1 over b minus a part in the front. So don't. Okay. All right, that's the formula. Good. Now, I stopped right here because I want to save some time. What else should I be doing with these in order to properly take the antiderivatives? I'm just going to change the exponents or the radicals into exponents. So that's a 2x to the 1/2 minus 3. This is on the bottom, so that's why it's an x to a negative 1/2. Okay, dx. Okay. So now it's just computation. So it's going to be 1/5. I'm going to find the antiderivative of this. So that's a 2 times x to the 3/2 divided by 3/2. Yes, you increase the power by 1. Minus 3 times x to the negative 1/2 plus 1 is positive 1/2 divided by 1/2. That between 4 and 9. Okay. So that's 1/5. When you, and I'm going to start plugging in the values, but also simplifying. So to divide by 3/2 means to multiply by 2/3. So 2 times 2/3 is 4/3, right? So this gets flipped up and down, and it's going to be a 2 times 2 over 3. So that's 4 over 3. Now plug in the 9. Again, your calculator will figure that out. Minus 3 times dividing by a half means to multiply by 2. And then again, I'm plugging in the 9 first. So I just kind of did 2 steps in one to save some time. And now we'll do the same thing, 4/3. But plug in the 4. Minus 6, plug in the 4. Again, don't forget always the upper limit of integration first, then the lower limit of integration second, and then the 1/5 of the front. Put this in your calculator, figure out all the values. Looks like my calculator, and again, don't forget to multiply by 1/5, so it looks like the values in there are an 18 minus is going to be a plus 1 1/3, so 1.333. So that's 19.333 divided by 5, which is about a 3.86. So that's the average value that this function takes from 4 to 9. That's it. So let's say this, an investment of $1,000 is compounded continuously at a rate of, let's say, 5%. Okay, what we want to do is find the, well, you're guessing it, average value in the account. So the average amount, if you want, how much do you have on average in this account between the first and 5th year of investment. Okay, so first things first, we want to find the average value, yes, in the account. Now, average value means to do what? Find the area, right, or the integral from a to b. A and b are what? 1 and 5. And then divide by the width of this interval. So divide by 4, which is, again, means to multiply by a quarter. Okay, now I don't have a function, but we know how to find or set up this function. What is going to be the amount that you have in an account that's compounded continuously? I'm giving you the interest rate, and I'm giving you the principal, right? So that's simply the PERT formula. And what's the PERT formula? The principal is 1,000. E to the, what's the rate of growth? 5%, so 0.05, and it obviously depends on time. This one's a dt, I call the variable time. That's what it is. And what we want to do is we want to find the average. So after 1 year, you might have 1,000 a little bit. After 5 years, you might have 1,000 a little bit more. What I want to do is find the average value between the year 1 and year 5, right? But that's the value in the account simply from our PERT formula. Okay, so that's going to be a quarter. I'm just going to take the antiderivative of this, which I'll keep the 1,000, e to the 0.05 t divided by what? 0.05, and take this and evaluate it between 1 and 5. So taking the 1,000 and dividing it by a 0.05 gives you a 20,000, by the way. Okay, so that's just these two numbers put together. If you want, you can throw the 2,000 out with a 4, right? It's a product of 3 numbers, really. So if you want, it's like factoring out the 20,000. So the 20,000 times a quarter is really 5,000. And then the only numbers that where I'm going to put in the 5 are here. So that's all I have to put in my calculator, and then multiply it by the 5,000. It's fine. You could put it here, then multiply by a quarter at the very end. You see you'll get the same answer, so don't worry about it. So when you plug this in, you're going to find out that on average, you're going to have $1,163.77. Okay, now that's dollars, because it's the amount, and we know what this function's about, right? What the y values are. So the y values of this function is the amount of money in the account, right? So that's dollars. All right. And let's just do one more problem, and then we'll be done with this section. Okay. So here it is. It says, that's another thing that we use this formula for. Taking average temperature, here, I'm going to say this, the temperature in a city is changing according to this formula. The temperature at time t is negative 0.3 t squared plus 4t plus 50 degrees Fahrenheit. Yes. So really, what does that simply mean? Kind of at time 0, right? So at midnight, yes, you are starting with 50 degrees Fahrenheit. And this is a what? It's an upward looking, it's a downward looking parabola. I meant it first goes up. So it's a downward looking parabola, right? So what does a downward looking parabola look like? It goes up, yes, and then it's just going to go down. So what we want to do is we want to figure out over the 24-hour period, wherever that might hit, right? What's the average temperature in the city? That's what we're going to want to figure out from midnight to the next midnight. And sure enough, just as it should be, right? The temperatures are starting to rise, right? You'll have your highest value maybe around afternoon, yes, and then you're going back. And so again, maybe the midnight's about here. And this might not quite be a very accurate description, but I tried to figure out a formula or take a function that might describe what the temperature really looks like. Yes, so, and really after midnight, it first actually goes down. So you're actually on the downfall, then it first, and then it goes up. But yes, let's just say that. Okay, so all we want to do is we want to find the average temperature between the hours of 10 a.m. and 3 p.m. Well, that's nice. Okay, so we want the average between certain times of the day. Okay, only. Okay, and sure enough, there's infinitely many readings between 10 a.m. and 3 p.m. We just want to find the average of that, yes, whatever that might be. So obviously, find the average temperature. That's the temperature function given right here. So the average temperature, right, is going to equal to the integral from a to b. We're going to have to figure that out. 1 over b minus a. Yes, so what are these? I should have said what t is. T is time since midnight. I did say it, but I didn't write it, so it'd be a good idea to write it. Now it's clear. Okay, so 10 a.m. is how many hours since midnight? 10 a.m. is 10 hours later, yes? Whoops. 3 p.m. is how many hours after midnight? If you think of the 24-hour whatever time measurement rather than the 12 hours a.m. and p.m., 3 p.m. is 3 hours after noon, so that's 15. Yes, it's 15 hours. Okay, so 10 hours later, and that's 15 hours later. Yes, 3 p.m. Okay, that's it of this function. What's the function? Negative 0.3 t squared plus 4t plus 50 dt. Okay, the function value, or I should say the name of the variable is t this time. So it's 1/5, not integral because we'll take the integral. Those are limits of integration between 10 and 15, yes? So let's go straight and find the antiderivative of that. So what's the antiderivative of that? It's negative, we'll keep the 0.3, t to the third over 3 plus 4 t squared over 2, right? Plus 50t. That's it. So there's going to be 1/5, yes? I'm going to plug in the values already, but I'm going to make this prettier. 0.03 divided by 3 is 0.1, not 0.03, but 0.3 divided by 3, and of course don't forget it's a negative. 4 divided by 2 is 2, so these are the values I'm going to plug this into. Okay, so first I'll put in a 15, so negative 0.1, 15 cubed, plus 2, right, from the 4 over 2, 15 squared, plus 50 times 15 minus, do the same thing but plug in a 10, negative 0.1, 10 to the third, plus 2 times 10 squared, plus 50 times 10. Yeah. Okay, there it is, yes. Okay, and again, put all of this in your calculator, whatever it is, put it in. Make sure you nicely group things. Don't mess it up on entering things in your calculator, right? Think about the order of operations, yes. So it's a 15 that's being cubed first, then you multiply by negative 0.1, and so on and so on. Make sure you put this in correctly, and then don't forget to divide also by 5 or multiply by 1/5. So it turns out the average temperature is going to be 52.5 degrees Fahrenheit, so not that much. Okay, so this is it. That's what we use. Again, it's just using the formulas, the definite integral formula, for yet another reason. So what you're going to have to do is really be careful, because again, a definite integral, if we just want to ask for the area under the curve as we did in 5.4, between so and so, there's no dividing, right, by b minus a. If we just find, what other applications did we do in 5.4? We did find the accumulated total, right, accumulated cost between units 10 and 15. There is no dividing. The only time you're dividing by the width of the interval is when we are asking for the average temperature. And again, same thing with the other problems, we're giving you the rate of change, and then we're asking you for the accumulated value, or we're giving you the marginal cost and we're asking you for the total cost between. This is just the function itself, right? It's not its derivative. So find the average value of a function. That's your formula, right? What was your formula? Let me go back to page 1. Right here, there's your formula. The average value, yes, is simply the area, right, or the integral in that function divided by the width of the interval. So that's it. All right.